Good day. This video presents an overview of the working principle of a refrigerator, focusing on the vapor compression refrigeration cycle and its four major components. The four components of vapor compression system: compressor, condenser, expansion valve, and evaporator. This is the cooling space. The evaporator is located that the evaporator in a refrigeration system is a heat exchanger which transfer heat from the substance being cooled to a boiling refrigerant. The purpose of the refrigeration system is to remove heat from air, water, or some other substance. This removal is performed by the evaporator. The condenser is at the back inside of Pujidenso refrigerator. Condenser receives superheated refrigerant from the compressor, remove the superheat, and then liquefy the refrigerant. It is the ultimate point of heat rejection from the refrigeration system. Some abundant fluid such as air or water carries away the heat. This fluid characterizes the condenser as air-cooled or water-cooled. Inside of this refrigerator, there is an expansion valve. The purpose of the expansion device is twofold. Number 1, it must reduce the pressure of the liquid refrigerant. Number 2, it must regulate the flow of the refrigerant to the evaporator. In the bottom at the back, there's a compressor. Compressor is the heart of the vapor compression system. The three most common types of refrigeration compressors are the reciprocating, rotary, and centrifugal. The reciprocating compressor consists of a piston moving back and forth in a cylinder with suction and discharge valves arranged to allow pumping to take place. The rotary and centrifugal compressors have rotating members. The rotary compressor is a positive displacement machine, whereas the centrifugal compressor operates by centrifugal force. This is how thermostatic expansion valves work and the processes of standard vapor compression cycle. At the point 1 to point 2, reversible and adiabatic compression from saturated vapor to the condenser pressure. At the point 2 to point 3, reversible rejection of heat at constant pressure, superheating, and condensation. At the point 3 to point 4, a reversible expansion at constant enthalpy from saturated liquid to the evaporator pressure. At the point 4 to point 1, reversible addition of heat at constant pressure and evaporation to saturated vapor.